a more cottage industry. It's a small group even by 2000, and then with Beijing, and then Liobin as a label. So by 2003, and then it's a bit more a bit more international, and then a few more the ecosystem is more mature. And by 2000, and when 10 years from that point, it looks more structured. And then our first 2 decades were summarized in a review this year. So this is the development here. But and then we tell the stories on what happens at the end. So 2002, Beijing, at its retirement, becomes the Beijing Tsinghua University's engineering physics, a visiting scientist, and his job is to establish a high energy experimental program in Tsinghua University. This is I give it a start because the junior is retired. He may not do that. He could be a consultant. He could be a consultant to a high-tech firm and then have an easier life. But this is his choice. He chooses to tackle the challenge of triggering a high energy physics program in a major university in China. And then I give it 2 stars here. The Tsinghua University would join IHAP under Li Jing for the Taiwan Fanyingdui. It's a reactor. Zhongwei did the neutrino experiment. So this is really in black and white at the MOU. So this major university in China would join us as the first generation process. I give it 2 stars because again it is not natural. So given the status, given the students, they have many other choices. So why should they trust us? Why should they trust me? It is still a mystery. Okay, but we still have another 2 stars. So the Tsinghua University comes. So things may evolve differently, and then Li Jing and I start building this new group, but suggested instead. So there's a group that comes and say explicitly in black and white that they would like to come to Taiwan and work on reactor neutrinos. But then we instead suggested that maybe they can do something else. Don't come to Taiwan, go somewhere else. And they spearheaded a light dark matter project in the new underground laboratory in Korea, Yangyang, using a low pressure detector which is being developed here. So this is again not a very natural move. And then, but this is we tune in, and then looking back, there are various reasons that brings to that. Because we are developing this low energy detector technique, so it should be applicable to both neutrinos and dark matter. It would be so it is necessary. It is good that another branch of our operations would try to explore how far we can go. And the light dark matter, then an obscure subject, is ready to have its windows open. This is what we feel. And indeed, this is by now a very hot subject, and we have contributed partially to opening up the doors of this as a subject of intense interest. So, and also, our searches for other underground sites in Taiwan do not provide very appetizing candidates. For the first 5 years, 6 years, we did try to look for underground possibilities in Taiwan, but they are not very good sites. So it didn't go too far. And also, we also tried to look for reactor sites for the Theta 1-3 project. But again, this didn't do very competitive locations compared to the locations in, for instance, in Daya Bay, which eventually could provide the best measurements on Theta 1-3. So, and for the group, we see the potentials and ambitions of the team, and feel that it's necessary to guide them to meaningful challenges with long-term growth and prospects. So we know that some birds cannot be caged. So we should give them something of challenge so that and see how far they go. So this is some of the rationales that lead to that selection, that choice. Okay, and then, but after that, I was too busy to really invest time on this dark matter project because locally I have a hardware program, that data analysis, and then it's quite busy. And also we have new groups joining from India and from Turkey, so we have to consolidate working relationship with them. And also my family affairs also get me occupied. I was rather busy and other things. But meanwhile, the Tsinghua team struggled on almost a Wujun Zhuozhan at this lab with minimal support. But the it gathers momentum and visibility within the campus to the point that the Tsinghua leadership makes visits all the way to Yangyang, to Korea, and leadership means more than one, including their Vice President Kong Ke-jun, who would be instrumental in the subsequent development. So the ideas of underground lab of dark matter experiments start taking shape, not just on campus, but in China, in the team best prepared. 2008, 10 years ago, coincidentally, it is also the year of Liang Jihang, when we have the right time. My family affairs get settled, I have more time, and I become restless again. I learned from my collaborators that there may be interesting possibility at Sichuan, and the rest is history. So this underground laboratory is at Sichuan, China, and then the story goes that the physicists would watch TV news 10 years ago in conjunction with the Beijing Summer Olympics. The construction tunnel was completed, and they realized that there's a possibility over there, and then things got moved on very, very fast. It's the deepest and so the details we can skip. It's the deepest and largest underground laboratory in the world, and this is by now a major science and technology infrastructure project in China. It's supported at the national level. So we have a extremely deep rock overburden, and then we house it exploring there, and there will be new series of cadence that when this is completed, it will be look like this, the CJPLC. Yeah. So it attracts then an international press coverage, and then the various all the major press has reported that. And for us, for scientifically, we say it's a major review in our field, and that the first 10 years of both science and engineering was summarized in an article like that. Yeah, so which comes out last year, the first 10 years. And then for the CDEC experiment at CJPL, it follows the DNA of the reactor experiment. We have achieved competitive results in dark matter and X-ray, and most of all, it is an exercise of team and expertise building for possible future projects. So the dark matter limit, X-ray limit, a bunch of papers, and then the hardware at the first level. So what may be the future? So the founding fathers want to have international collaboration. So we remember that. So in the new haven, there's a big hole being dug, and then the hope is to deploy a one-ton germanium detector scope for dark matter, and in particular a neutrino subawated decay project. And this legit one-ton is an excellent candidate for such a project. So that this is artist perception. This is being built. It looks like this now, and then eventually we hope to get it like this with a big tank and with 1 ton of germanium inside. Legit is an international collaboration, and then it's quite 200 scientists, and then the goal is to eventually deploy a ton-scale germanium detector to cover the inverted hierarchy of the neutrino mass matrix. And who are they? So it's a major group from Europe, from the States, and the CDEC group from Asia. That is the world's expertise team for ultra-low background germanium detectors. And then the one-ton experiments, the location to be decided. So it is still like looking for site for Olympic Games. It's still up in the air. And our group is to do a case of hosting this experiment in this new underground laboratory. So the goal is to bring legend to Jinping laboratory, to 将传奇带到这个实验室。Okay. So if realized, this experiment will be the fractured particle physics experiment in Asia. It is a $1 billion project. But looking backward, the summit is as challenging and as daunting, perhaps haunting, perhaps chaotic as that we faced 20 years ago. Now, there are zillions of other reasons why it would work. We could get into technical problems here, details here. But the discovery of double winner game will be an instant Nobel Prize. So that gives us something to look up to. Yeah. So Now, so after all, it's the people's method. So with the generation 1, we have myself, and then Zhongyuan, and then Li Xin. Generation 2, Ventesh, from India, and who is now a professor in India. Mohammed Dennis in Turkey. Li Xin is now a professor in Sichuan University. He'll be here soon with us. Yue Chen is now a professor at Tsinghua. And then in China, they have G3 faculty members already. Yang Yitao and then Liu Shupai from Sichuan and also Tsinghua University. And then this is the CDEX group as well as the external groups. So the CDEX group, besides that, is emerging with the substantial manpower pool and expertise from the engineering physics department. And also, well, of course, we have the retired alumni with Li Xin, and then Jiang Zhongyuan is in San Diego, under the Californian sun. Li Xin is in Beijing, but still very active. He wrote a book last year, so it's amazing. Huh? Yeah, and then we have all our alumni having a gathering some time ago. So and then they have their aspirations, and then the aspiration, the one's aspiration will become our work, our G1, G2, G3, G4 members' work. So okay, so I give a summary on what we have been doing in the last 20 years. I hope that in 20 years from now, we would hope that to report exciting developments and maybe to fulfill some of the wish of the founding fathers of an international collaboration. So happy birthday! Stay hungry, stay foolish. The famous word from a famous man in a famous research institute. It couldn't be wrong. Thank you. Okay. Okay, fine. Challenge me. Okay, he knows a lot of things that I don't know.
Remember the sequence. In 1992, I dropped the letter of intent to join CDF. So after some effort in 1993 February, CDF collaboration admitted Taiwan group because they don't need new group, so it's not a change. But that part of the story I can tell later. And then remember in 1994, I meet same team in Grand Hotel, and then I have to drop the proposal to get money from Academia Sinica to join AMS in 1995. In 1996, at the same time, I'm working with Zhang Zhongyin on this neutrino experiment, reactor neutrino experiment. So in 1996, two things happened. Zhang Zhongyin's wife got breast cancer, so he think he needs to take care of his wife. And I'm already too busy. I cannot handle three experiments. And then one day I received a resume of Henry from Li Taifeng. I don't know how. Li Taifeng was from Caltech, and so somehow he got the CV of Henry, and somehow he knew we are working on neutrino experiment, and so he didn't come himself, asked someone to send a resume to me. And so I discussed with Zhang Zhongyin, and he said, okay, this looks like a good guy. And so I went to talk the chance of AMS preparation meeting. I went to CERN and went to his office and talked to him. Maybe you didn't know, but I know you. And so that's the first time. And then I think I talked to him the second time, and I said, we want you to come back to Taiwan and lead this Texano experiment. Texano was Taiwan experiment on neutrino observation. It's a name coined by Zhang Zhongyin. And so that is history. So after some consideration, as you said, eventually he came back. Okay, so that's part of the
Sorry, we don't have time for questions, and we have already 10 minutes late.
Yes, yeah. Well, okay, so the arrangement is that, okay, we have the afternoon of chit chat, and then some of the things you can show the details. And we learned that sometimes maybe we can in future occasions we will organize things chit chat like this to inspire more stories. So we would have a photo session. Yeah. And outside. So while everybody is here, then it's nice to take pictures of that. So that we have something to show 20 years from now. And then refreshments and